In today's video, we're going to be looking at the divisibility tests for 2, 3, 4, 5, 6, and 10. So if we start off with 2, any number divisible by 2 needs to be what? Let's have a look. So if we go 10 divided by 2, we get 5. If we do 4 divided by 2, we get 2. Now what about if we try 5 divided by 2? Does that work? No, it doesn't, does it? Now why is this? If we have a look at the numbers that do work, 10 and 4, we can notice that these are even numbers, whereas 5 is an odd number. Therefore, for a number to be divisible by 2, it needs to be even. So let's write that down. I'll do it over on the right-hand side here. So for any number to be divisible by 2, the number must be even. Numbers divisible by 2 must be even. Now let's have a look at 3. If we take 9 divided by 3, we know that that's 3. What about 18 divided by 3? Well, if you know your times tables, you'll know that that's 6. And if we have a look at 27 divided by 3, we can see that that is 9. Now, what about if we try 41 divided by 3? Does that work? It actually doesn't. The closest numbers we'll get is 39 divided by 3, which is 13, or 42 divided by 3, which is 14. Now to check if a number is divisible or not, we can actually just add our integers together. See, if we add 1 and 8 together, we get 9, and we know that 9 is divisible by 3. If we add 2 and 7 together, that also gives us 9, which we know is divisible by 3. If we add 3 and 9 together, we get 12, which is divisible by 3, but we can also check if 12 is divisible by 3 by going 1 plus 2, which gives us 3, and 3 is divisible by 3. Same with 42. 4 plus 2 gives us 6, which is divisible by 3, whereas 4 plus 1 gives us 5, which isn't divisible by 3. So for a number to be divisible by 3, the integers must add to a number that is divisible by 3. So for example, if we use 42 divided by 3, we can check 4 plus 2 gives us 6, which is divisible by 3. Therefore, we know that 42 is divisible by 3. Now let's take a look at 4. When we divide by 4, we have 8 divided by 4. We get 2, right? Another way to look at that is we can go 8 divided by 2 and then divide by 2 again. 8 divided by 2 is 4, and 4 divided by 2 is 2. So we actually get the same answer. So what we're doing here is we are halving a number twice, or we're dividing by 2 and then dividing by 2 again. Now we know that to divide by 2, the number needs to be even. So if we're dividing by 2 twice, it means both numbers need to be even. So let's test that. If we go 32, we want to go divided by 4, and we want to check if it's divisible by 4. So we can check, is 32 divisible by 2? Well, 32 is even, so it has to be. we know that that is 16. So 16 is our answer. Is 16 even? It is, which means that we can divide 16 by 2 again. So if we go 16 divided by 2, we will get 8. Now these two is just taking 32 and dividing it by 4 because we divided by 2 twice. So we now know that that will give us the same answer here, 8. Let's do a second example. If we have 60, we'll do 60. If we have 60 divided by 4, the first thing we want to check is if 60 is divisible by 2. Now 60 is even, so it is going to be divisible by 2, and half of 60 is 30. Now our second step is to check if 30 is even and can therefore be divided by 2. Now 30 is even, which means we can divide it by 2 again. Half of 30 gives us 15. Now once again, these are our two different steps to check that that we can divide by 4, and this will be our answer. So we can rewrite it as 60 divided by 4 gives us 15. So let's add that to our divisibility tests. We've got 4, and our numbers must be divisible by 2 twice. So to write an example for that, we can use our 32 divided by 4, and we'll check 32 divided by 2 works. The answer is 16. And then we need to check 16 divided by 2 also works, which gives us 8. And we therefore know that 32 is divisible by 4 and will in fact give us 8. Now let's take a look at 5. So if we have a look at our 5 multiplication tables, we get 5 times 1, which is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. And it goes on and on. We can catch the same pattern as well if we count by 5. 5, 10, 15, 20, 25, 30, 35, etc. and etc. Now if we have a look at our last digit of these numbers here, we end in a 5, a 0, a 5, a 0. If we keep going, 25 ends in 5, 30 ends in 0, 35 ends in 5, 40 ends in 0. So we can know now that a number to be divisible by 5 needs to end in either 5 or 0. And we can actually test this. Is 27 divisible by 5? Well, 27 isn't in our 5 times tables, which means it's not. And it also doesn't end in a 5 or a 0. So therefore, we've just proven that that is how it works. So let's write it out. For 5, our numbers must end in a 5 or 0, which is our ones place value. So we can go, for example, 25 ends in 5, therefore it is divisible by 5, whereas 27 ends in a 7, so it won't be divisible by 5. For a number to be divisible by 6, we know that 6 is made up of 2 times 3. So if we have a look at 36, which is divisible by 6, we know this because it's one of our squares. 36 divided by 6 is 6. But if we wanted to just check if 36 is divisible by 6, we could first check if 36 is divisible by 2, which it is, because 36 is even. And we can check if 36 is divisible by 3, which it is, because 3 plus 6 gives us 9. Therefore, because it's divisible by both 2 and 3, it's divisible by 6. Let's test an example where this might not work. If we check 64. We want to check if 64 is divisible by 6. We'll first check if 64 is divisible by 2. Now this will work because 64 is an even number. The next thing we need to do is check if 64 is divisible by 3. So we'll check 6 plus 4 gives us 10, which isn't a number that's divisible by 3. So 64 isn't divisible by 3. Now check in your calculator, 64 divided by 6 gives us 10.6 recurring, which is a decimal. So therefore 64 is not divisible by 6. We can therefore know that for a number to be divisible by 6, it needs to be divisible by both 2 and 3. Not one or the other, but both. We'll write our example down of 36 divisible by 6. So first check 36 divisible by 2, which works, and 36 divisible by 3, which also works. Therefore, 36 is divisible by 6. And we'll check our counterexample, which proves that you need both 2 and 3 to be divisible. So we'll use 64. We want to check if it's divisible by 6. So 64 divided by 2 does work, as we proved before. And 64 divided by 3 doesn't work. Therefore, 64 is not divisible. Now, the last number we will look at in today's video is our divisibility by 10. So let's take a look. If we have our 10 times tables, we know we've got 10, 20, 30, 40, 50. Or if you count by tens, you'll get the same thing. Now, if we have a look at the last number of all of these, or our ones value, we can see that they are all 0. So we might think, okay, the ones value must be a 0. Let's see if we can disprove this. So find a number that doesn't end in 0 but is divisible by 10. So if we have a look at, say, 27, can we divide this by 10? No, because we can divide 20 by 10. We'll get 2. But 7 is not divisible by 10 easily. It's too small a number. Let's check one more example. If we go with 34, whether that is divisible by 10. So 30 is divisible by 10, right? We'll get 3. But 4, which would be our remainder, is not divisible by 10 because 4 is smaller than 10, so it's not. Therefore, we know that our initial evaluation or statement there is true. For a number to be divisible by 10, the ones place value needs to be a 0. So, for example, 10, 20, 30, 40, etc. are all divisible by 10. Feel free to go back and write these down in your book so you have them for later, and I hope this was helpful.